All right, so based on that definition of the reference angle, let's finish the unit circle that we started yesterday. So remember, we have all of our special angles on our unit circle. And we talked about the ordered pairs of the points where the terminal side crosses our actual circle. So the distance from the center out to that point is going to be 1, because that's the definition of a unit circle, that it has a radius of 1. Okay, and so we're trying to come up with the ordered pairs of those points where the terminal side intersects with the circle, because from that ordered pair, then we can tell our cosine and our sine. So in the last lesson, we talked a little bit about the first quadrant. We said that with our first angle here being pi over 6, which is the same as a 30-degree angle, that we knew from what we did in a previous lesson that cosine was going to be square root of 3 over 2, and that sine should be 1/2. So we can use that information in order to set up our ordered pair, because we know cosine correlates to the x coordinate and sine correlates to the y coordinate. Okay, and so we can do that all the way around with these first quadrant angles. Our 45-degree angle, or pi over 4 radian angle, is going to have square root of 2 over 2 for both x and y, because that is cosine and sine. And our 60-degree angle, or pi over 3 radian angle, would be at 1/2 comma square root of 3 over 2. We also know that if we're on the positive y-axis, then our point's going to be at 0, 1. But then as we continue around the circle, notice what happens with this next angle. So our actual angle here is starting from standard position and going around, rotating to this point. So this is a 120-degree angle, which is the same as a 2 pi over 3 radian angle. Okay? Now, what's key here is to not look at the angle itself, but as was discussed in that little video clip you saw at the beginning here, we actually are more interested in the reference angle. And so this reference angle, created by our horizontal x-axis and this terminal side, is going to be this angle right here, which is pi over 3. So using that, we come over here to the angle that was pi over 3, and these numbers give us the same numbers for cosine and sine. But what's different is the positive negative signs. So in the second quadrant, we know that cosine has to be negative because we're going to the left of our y-axis, and sine has to be positive because we're going up. So we take the same 1/2 cosine that we got from our reference angle, pi over 3, but now we make it negative because it's in the second quadrant. And then we take our square root of 3 over 2, that gives us our sine, and that remains positive because, again, we're in the second quadrant, which is where sine is positive. Okay? And as you continue around, you can do that with every one of these angles. If I decide to go to our next angle, which is the 3 pi over 4, radian angle, again, we're talking about this rotation as being 3 pi over 4. But what we're really interested in is, again, this reference angle. And the reference angle is pi over 4. So that's why it's better if you can think about your angles in terms of radians. Because whatever your denominator is here gives you a hint as to what your reference angle should be for figuring out your sine and your cosine. And then negative on cosine, positive on sine, and you've got sine and cosine in the second quadrant. Okay, so you can do this all the way around. Same thing happens with our next angle, which is the 5 pi over 6. Again, notice we're using the same numbers as pi over 6. So our reference here now is pi over 6, but a negative cosine and a positive sine. Now when we get to our x-axis, we talked about that last lesson. We have a negative 1, 0 there for that point. But then as we continue on, we're now at an angle of 7 pi over 6, and this is our reference angle. But again, that denominator of 6 tells me my reference angle is the pi over 6 here. So I'm using square root of 3 over 2 for my first number, 1/2 for my second number. But now in the third quadrant, my cosine is negative because I went left, but I also have a sine that's negative because I'm going down to get to that point right there. So it's going to be a negative square root of 3 over 2 and a negative 1/2 for the cosine and sine in our third quadrant. And again, if we continue, our next angle would be 5 pi over 4. So pi over 4 is going to be our reference. Make them both negative. My next angle is going to be 4 pi over 3. So our reference is going to be pi over 3, this one here. Just make them both negative. And then we're back to an axis and a point of 0, -1. And then finally, our next angle, if we continue to rotate around, is going to be 5 pi over 3. So again, our reference is the pi over 3 angle, right? Because now our reference is here. So that's a pi over 3 angle, just like up here. Excuse me. And so again, we're using the same x and y values for cosine and sine, but now in the fourth quadrant, cosine is positive because we went to the right, but sine is still negative because we're going down. So our cosine x-coordinate stays positive 1/2, but our sine y-coordinate is going to become negative down here in the fourth quadrant. And then we would have our 7 pi over 4, which will have a reference of pi over 4, so that's going to go with this one. Again, just make the y negative in the fourth quadrant. And finally, we have our 11 pi over 6, so our reference would be pi over 6. Again, numbers are the same, just making the y coordinate negative. So these are what you need to know, and this is what the little shortcut at the end of yesterday's lesson is helping you with. You can figure out what your numbers should be based on the reference angle in the first quadrant, and then finalize your answer based on whether it should be positive or negative based on which quadrant you are in, which is why you need to know where these angles are so you know which quadrant you're in and what kind of signs you should have on your x and y cosine and sine answers. Okay, so now that you have an idea of what kinds of numbers our special angles should get, we're going to finish out this video with a couple of examples going back to the gentleman who started our video for us. So pay attention, take some good notes, and we'll see you next lesson.